Okay. Hey, hopefully they'll hear this and come over here. I'm Christy Bergman. I'm dev advocate at Zilliz. Feel free to connect with me, follow me. So we organize these events, these unstructured meetup events for people to have meaningful discussions and learn collaboratively about Gen AI and unstructured data. So people may be wondering about what is a vector database? When it comes to Gen AI, you can think of the three pillars of compute, NVIDIA, Intel, for example, models, OpenAI, and data. And in Gen AI, all the data is vectors. And vector databases are about storing, indexing, and searching those vectors. So Milvus is an open source vector database. It was donated to the Linux Foundation, so it has a very generous free license that you can build on. It has 27,000 GitHub stars, and also and it's used in the closed source managed version of Milvus called Zilliz Cloud. So you want to take a picture of this, the Milvus GitHub. We're going to do a raffle tonight of some swag. Oh, thanks. Some swag sweatshirts, Zilliz slag sweatshirts. So usually I like to ask, how many people here have heard of Milvus or Zilliz? Okay, I see some hands. And how many people are using Milvus and Zilliz? Okay, I see more hands. So if anybody would like to give a community demo, find me and I can put you on the stage. Happy to do that. And then another thing is, if you have a job opening, we'll give you time at the end to announce your job opening. All right, so with that, I'm gonna bring Chris here, who wants to say some more. There we go. Hopefully.
Thank you. Okay, folks, I think there's a few more people in the back. Come on over, grab a seat. We want to get started. We've got a really great lineup today. Let me go. Okay, just really briefly, just want to remind everybody that when we think about Gen AI, we think about it in these three pillars. I think we're all aware of, what is in computation, right? The heavyweights, NVIDIA, Intel, et cetera. And of course, all the wonderful models that are out there. But when it comes to data, there's actually a lot of opportunity for all of us. And so I just wanted to highlight that to everybody. And of course, in data, we have a vector database to store all your vector embeddings. But similar to a traditional database, there's actually lots of other things that have yet to be built, or they're just being built. So data pipelines, observability, security, encryption, blah, blah, blah. All these things are required in order to make vector databases really effective and really make these Gen AI applications really powerful. And I share this with you because I don't know why this isn't working, Christy. Because we want to inspire everybody here. Maybe you're thinking about a startup, maybe you're building something already. I think there's a lot of opportunity for someone to think about those different parts of supporting data, especially with in the realm of Gen AI. And it's okay. And as Christy mentioned, that's why we are hosting this meetup on a regular basis. We have it here and in the South Bay, New York, Berlin, et cetera. And at the end of the year, we're actually going to hold a summit. And hopefully, some of you guys will build some really cool projects, and maybe you'll want to showcase it not just at our meetup, but at the summit. So I just wanted to plant that seed in everybody's head. And I don't know, maybe in a couple of weeks, we'll see something that you guys worked on. So thanks.
Thanks, Chris. All right, so we're going to have 3 talks and a community demo tonight. So our first speaker, I'm going to clear this stage for you. Our first speaker is Sourabh Agrawal. He's a co-founder and maintainer of UpTrain. He's been building machine learning models for the last 7 years, and one frequent source of frustration for him was the lack of great tools that answer a simple question: are my models in production performing as expected? So before starting UpTrain, he worked in investment banking and autonomous driving industries, and Sourabh is going to speak to us tonight about challenges associated with using LLM as a judge. Welcome, Sourabh.
Hey, thanks a lot for inviting me, and really excited to share our learnings of building UpTrain in terms of how we can leverage LLM evaluations to make production grade applications, and how we can deploy LLM applications in a safe as well as in a confident manner. Let me get this set up first. So yeah, my name is Sourabh. I'm the maintainer and co-founder of UpTrain AI. We basically are an open source LLM evaluations framework. So we help make your LLM applications better by giving you scores on how well they are doing. So I'm sure like many of you must have heard about evaluations, especially in recent times when there is a big push to get these prototypes out of the prototype stage and give it into the hands of millions and billions of users. So when we think about evaluations, right, like it is tricky, but it's also a very well needed problem. So the reason we need evaluations is because if you do it manually, if you just skim through all the logs and figure out whether it is working well or not, it's hard, it's time consuming, and it's not scalable because it's subjective to each of the developer. Whatever judgments you do depends upon you as a person, and it may not align well with your team. So that's why there is a lot of advancements which has happened in terms of figuring out on how we can scale this evaluations methodology, how we can use LLM themselves as a judge to evaluate the quality of the outputs which we are getting from LLMs only. So yeah, I mean, like LLM applications, building evals is also hard. Building evals is also tricky. If you just prompt, let's say GPT-4 and ask them that, okay, here is my question, here is my context, this is my response, is it good or bad? The output is as good as a coin toss. Sometimes you might get a score of 1, sometimes you might get a score of 0. Both of them will not mean a lot. But this sets a good base for us to figure out what are the different techniques on how we can extend this framework and make something which is really useful. So to begin with, I want to discuss, what are the things we should be evaluating upon. So broadly, we classify this set of evaluations into 4 categories. The first one is the response quality. If I'm giving a response back to my user, is the response even relevant with respect to the query which the user has asked? Is it answering all aspects of the user? Is it concise enough, or is it too verbose for the user to get frustrated and leave the application? Second, we talk about context awareness. As you might know, 90% of the LLM applications today are RAG-based. So they take some context from vector databases, and then they utilize that context to give the response. So naturally, the first question we have to ask here is is the context which we are retrieving, is it good enough? Is the response which I'm getting, is it grounded by this context? Or is my model hallucinating and giving a response which is independent of whatever knowledge we are providing it to? Thirdly, most of the applications, if you think from a chatbot perspective, it's all multi-turn. It's not like a user asks a question and you give a response. It's the user is conversing with the AI, and typically the user comes with an objective. Let's say they want to get some support query resolved, or they want to get answer for a particular question. And the AI itself also has an objective in terms of helping the users or getting more details from the users and so on. So when you think about evaluating the whole conversation, it's about, is the user query being resolved in line of the whole, taking the whole conversation as a whole. And finally, safety is a very important topic. We want to use evaluators to detect jailbreaks, detect prompt injections, and make sure that our users are not misusing the applications we are building for them. And finally, like as you kind of start with these simpler checks, simpler predefined evaluations, there are like more advanced things which you need to look at. So when you think about response quality, even though your response is correct, like sometimes user wants citations because they are worried that the model has hallucinated. They want to know whether the response have the appropriate sources to assign the information it is providing. There might be some custom instructions which you as a developer want, like you don't want a certain tone, you don't want to disclose some confidential information, or you want your model output to follow a certain structure. So there could be some custom instructions which you want the output to be followed. And that's where there are like more advanced ways to evaluate the models on these custom instructions. Thinking about a context awareness, like even though your context might be good, you also want to make sure that it's optimal, because as we know, like if we just cramp everything in the context window of the LLM, it starts degrading. So you want to make sure that the retrieved context is optimal. You want to make sure that the embedding model you're using is well tuned for your use case. You are picking the best embedding model for your scenario, not the one which is like the best on the MTV data set. Finally, you want to ensure that your context does not have any conflicting information, because if there are conflicts in the context, the model may get confused and does not give a good result. Similarly, on the language quality, even though the LLM outputs are pretty good from a natural human sounding point of view, you want to ensure that over a long range, let's say you're having a multi-turn conversation, the model is coherent across this whole conversation. Or if you're using it to write a blog, it's coherent across, the first paragraph and the last paragraph. A common example could be like, let's say you wanted to write about American football, right? And then you don't want that towards the end it starts confusing football and soccer, because these two have different meanings. Similarly, on the safety point of view, it's not just about detecting jailbreaks, it's also understanding as a whole if the user is misusing the API or misusing the LLM application. And then as we go to more fun stuff around agents and conversations, we want to check whether the planning which we got from the agent, is it optimal? Whether the number of steps which we require to achieve the objective, is it optimal? Like we want to give the value to the user as quickly as possible. And this is like one of the core things we see developers evaluating their LLM applications upon. And then finally, if you have a coding task, like there are some code specific checks in terms of whether the syntax is correct, whether it is compatible with the existing code base, whether it's kind of performing well on the unit test, and so on and so on. So yeah, these are the different dimensions. Like there are around like 30, 35 plus LLM like dimensions on how to evaluate the LLM quality upon. And now we will look at what are the different techniques. So when we say like we want to use LLM as a judge, we will dive into like what are the different ways on this could be done. So broadly, there are two different variations on how people use LLM as a judge. The most common one is the prompt-based evaluation, where you prompt GPT with the necessary context, with the necessary prompt, and ask them to give out a score. The good part about this is like it's easy to get started because everyone has access to all the state-of-the-art LLMs, and you can like write your own prompt and get started and start getting some outputs. As well as like, since you are leveraging all these closed source APIs, you don't need to worry about the infrastructure. You don't need to worry about hosting and all the other headaches which come with that. And the second technique is tuning based. So here, instead of using a closed source API, you are tuning, let's say, an open source model, let's say Llama 3, or one of the models from Hugging Face, to act as an evaluator, fine-tuned for your use case. So this is more cost effective because you have full control over the hosting. So you can kind of manage the cost and you don't need to pay per usage. And at the same time, yeah, you're leveraging the open source. So you have like more control over the quality of your evaluator and so on. So since prompt-based evaluation is currently like the more popular method because it's easy to get started and easy to kind of expand into, and we see the closed source models also getting better and better. So I'll be speaking more about what are the different ways of prompt-based evaluation. So there are like 4 key techniques. The first one is score-based evaluation. So, I mean, it's simple, like, you give the data to your LLM and you ask it to give me a score between 1 to 10, let's say, to rate relevance of the given context, or to rate relevance of the given response, or to rate like tonality of the given response. So you can like configure like what thing you want to evaluate upon. It gives back a score between 1 to 10. It doesn't work really well because LLMs are like poorly conditioned. If you ask it to generate a random number between 1 to 10, it's not a uniform distribution. Like some numbers are preferred more than other numbers. So then hence, like, this is what the community started with, but it doesn't necessarily give really good outputs. So then the second step like is something called like a classification based approach, where you transform the scoring into a classification problem. So instead of saying that I want an output between 1 to 10, you say that I want an output which is either good, average, or poor. Or you can like expand more classes and provide few short examples. But the idea is that instead of just giving back a score, you ask it to grade. Is it like a good response? It is an average response? Is it a poor response? Is it a horrible response, and so on? So this performs much more better, like, because now the LLMs, like, it's a simpler problem statement, and the LLMs also have like some examples and few shots to learn from it. One issue which happens here is the position bias. Typically, like if you put definition of good at the top, the model is more likely to choose good as compared to the other two. Whereas like if you put poor at the top, it's like more likely to choose the one which is like, at the top. But again, like this position bias can be managed in different ways. Thirdly, like in many scenarios, it's not just like you want to rate the quality, you want to compare two different models. Let's say you are comparing OpenAI models versus Claude models. Or even let's say, with GPT-4o, you are changing your prompts and you want to compare whether your old prompt is better than the new prompt. So in this case, like you do something called a pairwise comparison, where you give both the outputs and you ask LLM which of the two is performing better. Again, here, like the position bias is more obvious because it's not just the definition of the term, it's essentially like you're putting the two responses, one at the top and one at the bottom. But yeah, this also is a very valid method if you want to compare two different prompts or two different models. And finally, like the more complicated or more advanced techniques are the ensemble techniques. Like before the session, I was talking to like Christy, and she mentioned that cost is a big issue, like, when it comes to evaluation. And ensemble is a great method where you can use like a series of low cost, low quality evaluators, let's say GPT 3.5 or like, models in that domain. And you can do some sort of a majority voting, or you can have some agentic approach or theory of thought prompting to evaluate the quality of your evaluator. So even if you use like a suboptimal model, you can get really good results by taking majority voting or like doing the same calculation like multiple times. So these are the different techniques, and like, there are some limitations which we saw, but I just wanted to highlight all of these limitations. So definitely, like, as the case with any LLM, like biases do exist when it comes to evaluation. And this is something, one needs to be mindful of. There is an order bias, like the thing which you put on the top is more likely to get selected. There is egocentric bias where like, LLMs have a tendency to choose their own output or rate their own output better than other outputs. And then like there is a length bias, like, some LLMs prefer longer responses, some prefer shorter responses, which may or may not truly reflect the quality of the response. Other things, which you need to keep in mind is the robustness. Like you need your evaluations to be consistent. As you evaluate the same thing multiple times, it needs to be consistent. You need to incorporate domain-specific knowledge. So for example, like let's say you're building a chatbot for developers, right? There are many things which we as developers inherently know. Like, when I'm getting response from an API, I don't expect it to explain what an API means, because this is something as a developer, I know that this is obvious for me, but it may not be obvious for a non-technical person. So whenever you are evaluating, let's say, the quality of the response, you need to give this information about the persona of your user so that the LLM understands that what is obvious and what is not obvious for your users, and use this appropriately to judge the quality. And finally, the cost of evaluating is a big concern. You don't want the cost to be higher than, let's say, the cost of generation. And yeah, we will look at like some tricks on how we can lower those costs. So yeah, I think I would say the holy grail is like, keep the evaluation as objective as possible. So to give you an example, right, let's say you're checking for conciseness. Now, if I give you a response and I ask you like whether it's a concise response or not, it's really difficult to say, right? Because it's a very subjective evaluation, right? Like I might say that, okay, this is concise enough for me. Whereas someone else might say that, this looks long, this looks verbose, it's like 10 sentences, it should be 5 sentences and so on. So that's why, like, one way we do at UpTrain is like, we break down the response into meaningful subparts. So let's say, you have a response which is like, 10 paragraphs long. You kind of break it down into like meaningful subparts, and then you check each of them individually and see whether, they are contributing to the overall quality of the response, whether this is needed or not. And then finally, you can take like a ratio of the relevant portions divided by the total portions. And this gives you a much better sense of the conciseness as compared to just going and asking LLM to give a score. I mentioned about like Likert style grading. Like basically you want to use classification. So you want to use yes, no, or you want to use categories. One important point to think here is like, whenever you opt for grading, always have, a case where you have a scenario like a maybe or an average, or like, the response quality is neither good nor bad, because there are many scenarios where your LLM is at the edge, whether they're not entirely, it does not qualify for a good one, whereas it does not qualify for a 0. So they might want to give a score of 0.5. So you should always incorporate a maybe or like a in between scenario in the classes which you choose for for grading. And yeah, to combat cost, you should leverage cheaper LLMs as much as possible. There are different ways, like you can do majority voting. You can run your whole data set through these cheap LLMs and get the confidence scores. And whenever the evaluators are not confident, only run those cases through a more expensive LLM or a high quality LLM. So that way you are able to get good quality scores, at the same time keep your costs as bay. And finally, if you're working, okay, yeah, I'll just hurry up. And finally, if you're working for a particular domain, let's say law or some other domain, fine tuning works better than using standard LLMs as evaluators. So yeah, I typically think of evaluations in 2 stages. If you're doing pre-prod, like you are making an application, ideally start with 50 data points, run different metrics, understand how your prompt experiment is working. Look at cases where the new version is better. It will give you a sense of what improvements are happening. And look at cases where the old is better. It will give you a sense of what needs to, what more improvements you need to do. And secondly, once you have things in production, at that time, evaluation can be used to identify failure cases. It can be used to identify blind spots. So run key evaluation, select the failure cases from them, and do some kind of root cause analysis. We have different templates for root cause analysis in UpTrain, which you can check out. And that will tell you whether, what kind of issue is there. Is it a retrieval issue, utilization issue, citation issue, and so on. So I'll quickly show you a very, very brief demo of how UpTrain works. So yeah, the idea is UpTrain to kind of make it as simple as possible. So, sorry? Oh, yeah. Okay, yeah. So the idea is make it as simple as possible. So we have it's an open source package. So, you can install it with pip. And then, yeah, you just define an evaluation LLM. So either you can use our managed version or open source version. If you're using open source, you need to provide your own API, like OpenAI API key, or design, choose which LLM to use, or you can choose the UpTrain API key. And then, yeah, then you need to define your data. So each data point is a question, context, and the response. And then for certain other cases, like evaluating conversations or evaluating codes, we have more fields which are required. But then you can get a data. So here I'm downloading a sample data set. And then, yeah, you have a query. So you just say log and evaluate. You give back which evaluations you want to run. So we have classes for each of the different evals, which I've talked about, like factual accuracy, response completeness, conciseness, conversation quality, and so on. And you just send it okay, this is my data. These are the evals I want to run. And it will give back the results. So it will give back the scores and the explanations to kind of understand. and everything gets logged. So we also have like dashboards as part of our package. So you can like check them out, and like, you can, let me just show you the results. So yeah, you will see here, like, all this different information in terms of like, what the scores were, what the explanation was, like, why did your module choose a particular evaluation score, and so on. You can run different experiments, compare different models, compare different prompts, use it for monitoring, use it to identify failure cases, and so on. So yeah, check it out. It's uptrain.ai/uptrain. Thank you.
Thank you. I think we have time for one or two questions. I see a question right here.
So when you talk about prompt-based technologies, you said that there's a bias called pairwise comparison bias. So I was wondering if you can elaborate more on this.
Yeah, sure. So basically this position bias, which happens in like pairwise comparison, is essentially like, let's say you have like two responses, right, coming from two different models. So you say that here is response 1, here is response 2, and you ask LLM which of the two is better. Typically what we have seen is like, depending upon whether you put the same response at the top or at the bottom, the scores might change. And that's a bias because like, different, I mean, at the end of the day, like, different words in the context have like different attention, and like, it gets, the output differs based on like, what's the location of the relevant piece of information in the context. So if you have like, let's say GPT response and Claude response, if you put GPT response at the top, it might happen that it will prefer the GPT response. But for the same set of responses, if you put Claude response at the top, it might prefer the Claude response. So that's a position bias. And like, typically you want to like run it through multiple times to get like a more stable values, or like you want to kind of use like, some other methods where we generate some kind of reasoning and then have a better way to identify which of the two is better.
But isn't that a randomness or the stochastic nature of these probability-based models? It seems like it's not a bias that has a statistical importance. It's rather like a random thing.
Yeah, I mean, yeah, I agree. It's more of a random thing, but at the end of the day, you don't want the output of your evaluator to change depending upon like, which of the response is coming at the top, right? Because then it just means that you are not able to trust the values. Because if I put 1 at the top and it's giving a score of 1, and if I put the same thing at bottom and it's giving a score of like, 0, that means that, like the evaluator is not doing the job as objectively as we want it to be. So like, even though it's a property of LLMs, like, depends like based on how they are trained and like, how they kind of understand the context. But yeah, it's something which like, we want to ensure that we understand and we kind of address while using them as evaluators.
Thank you.
Will you be around afterwards for more questions? Okay, so I think I can take one more question.
Hi, it's a nice presentation. So I have a question regarding, question on the whole using LLMs as a judge, because when I worked on a similar product where we used LLMs as a judge to give evaluations for a lot of categories like completeness, relevancy of response and everything, it really matters what model do you use as a judge, especially when we used Claude Opus or GPT-4, the performance really varies a lot.
Yeah.
And even though you could trust Claude Opus or something for using LLM as a judge, it's really hard to understand what exactly is changing in the prompt, or what is making the performance to come down. It's really hard to understand why the scores are as given by the models. And I feel like all these evaluations are just needs to be changed, and there needs to be new kind of evaluations to compare the accuracies or performance of the models.
Yes. So, I mean, that's why, like, when I started, like, I said it is needed, but it's also like hard and tricky. So I completely hear you when you say, like, some of the numbers don't make sense. That's why I think if you really want to, if you want the evaluations to be useful, the key is to make them as objective as possible. If you just ask that, okay, is it a concise response? Is it a complete response? Is it a good response? It's a very subjective, right? I mean, what is good to you may not be good to me, right? But if instead of that, you kind of break it down into simpler portions, you define what good means, you actually say that, okay, like I'm looking for this criteria, whether it is satisfied or not. That's when these evaluations start making more sense. That's where you also see like, like if the evaluation is very objective in nature, you don't see like, each of the models giving different results. So what we, let's say, see at UpTrain is like most of the evaluations which are objective in nature, which we try to kind of transform everything into, we see like there is like less than like 1% variation between outputs of, either GPT 3.5 or GPT 4 or Claude or like, Llama 3 and so on. But at the same time, if you make it really objective, then yeah, even the same model, multiple runs, it will give different results. Different models will give like vastly different results and so on. So the way I look at it is like, you like there is a need, like I think they are like a good, like all these pre-configured metrics are a good way to start for you to get an understanding of these metrics. And obviously you need to configure them the right way. You cannot just prompt it like, give me a score. You have to configure them the right way. And then you have to like move into more advanced metrics, like define some custom evaluations. And like, so we have like something called a guideline evaluation where you can define your own custom guideline and see whether it is following it or not. And that way you get like more and more understanding of the quality, and you kind of understand like, which cases are performing worse, which cases are performing better. And like, it kind of help you provide more structure to your prompt engineering approach, and like, help you productionize your models in a more efficient way.
Yeah, just one last question. So since you have mentioned that there is bias in the language models when trying to judge the responses, right? So if you could get annotations on those responses for various questions, and then you do human evaluation, like use humans to verify those responses scores, and then train some smaller model or like 2 billion model or Llama 2 or something like that. And then you basically distill the knowledge. But I don't know if you have experimented whether it carries on the bias even to the fine-tuned model using the human verified annotations by GPT or Claude.
Yeah. So yeah, we definitely have conducted some experiments. Like what we have seen is like, if you want to build an evaluator which is like generic enough, like it can be used in all these different use cases, let's say for legal use case or finance use case, edtech use case, and so on. Fine tuning doesn't really help a lot because as you decrease the size, the knowledge of the model decreases. But if you want to focus on one specific domain, let's say only for legal, the fine tuning obviously like works better, and it helps you combat many of these biases. Like a good way which I have seen like to combat these biases is having a categorization approach, where like, you do a classification, whether it's a good response, a bad response, or an average response. And if you do it like, within an objective framework, like I have seen like, the cases of these biases like go down massively. Like, we see like more than like 90% agreement with like human evaluations, which is kind of close to like, what we see agreement between different humans also. So I believe if you use LLM-as-judge the right way, it can get like 90% of your job done. There would be like still some cases where you as a human or as a developer needs to look at those responses and make the final judgment. But yeah, it can like, help you, instead of looking at like 100 cases, you just need to look at those 10 difficult cases and like, complete your experiments.
Thank you.
All right, let's thank our speaker again. Thank you, Sourabh.
Thank you so much.
And I'd like to encourage everybody, keep those questions in mind about how to evaluate language systematically and fairly, because I think our last speaker is going to get you thinking even more about that. Okay, so our next speaker, Jiang Chen, is currently the head of AI platform and ecosystems at Zilliz. Before joining Zilliz, he worked as a tech lead and product manager at Google on search products. Jiang holds a master's degree in computer science from the University of Michigan, and he's going to speak today to us about building production-ready search pipelines with Spark and Milvus. Welcome, Jiang.
Okay, thanks. And that was a great talk, Sarah. I mean, we have done, at Zilliz, we have done a lot of evaluation work because we want to help our customers build like more, not only more performant, but with better quality search products and AI, applications. And I think one of the very insightful thing from the last talk, my takeaway is that you don't like the large language model to judge based on scores. You let it kind of give it a few short examples and let it categorize as good, mediocre and bad. That's very insightful. I want to kind of share some insights from another perspective, which is, once you have the say RAG pipelines or any kind of search applications built, now you have a Twitter demo. How do you scale it to something kind of more serious, more production ready? And how do you leverage the technology from Spark and Milvus to build those kind of data pipelines? So a bit about myself, I used to work for Google search indexing, and at Google we used to run gigantic pipelines to deal with the web scale data. So that creates a lot of kind of scalability problems, and our main job is to make sure that hundreds of billions of documents are indexed and continuously updated through very complex data pipelines, and also runs hundreds of machine learning models to extract the labels, to do semantic understanding, things like that. Within the last 12 months, we have seen a paradigm shift. It's like, well, you don't need 500 people team to do that. You just need something like Llama Index or LangChain and a vector database and large language model or embedding models. And now you can build a search pipeline, which is fantastic. However, there are some limitations, because with those kind of technologies, it's really easy to build some Twitter demo, but it's pretty difficult to scale it up to something that can serve billions of users and hundreds of billions of vectors, or like web scale operation. That's still a challenge. So that I want to share some of the learnings that I had from my experience at Google, and also just kind of put it into the new context of how do we build the AI applications based on those experience. So this whole story about AI powered search can come from the development of deep neural networks or deep learning techniques. So that in the past decade, the elastic search era. So the way that we do search is that we kind of extract the labels and keywords from the documents, like web page, or you can do this for images even, because usually images come with some kind of captions or text surrounding them, and then you can use the text as kind of hint about what this image is talking about. So anyhow, the search is based on kind of mechanics rather than probability. So with the deep neural network, there is a kind of brute force way of, I just developed a huge neural network with like millions, now billions of nodes or neurons. And then I just feed in the data into it and train it based on some objectives, and suddenly, just magically, it can output some meaningful information for you. I mean, it kind of learns what you are teaching with the data, and then just kind of repeat the thing. It can do pattern recognition. In this case, in your case, for search, we want to grasp the kind of the essence of the semantic from the text documents or images or voices, videos, and it can do this job really, really well. So once it does this, it outputs some kind of mathematical representation from the documents. In this case, they are vectors. So now we have a new data type. We need a new infrastructure or a new kind of database to manage those data and to do efficient retrieval from the vectors. So that comes the vector database, which is what we are doing with both the open source vector database called Milvus, and also the the commercial hosted version is called Zilliz Cloud. And once you have the vector, now you can do a lot of applications without the complex infrastructure. You can just have the embedding model, which is the model that's trained for kind of generating a meaningful vector representation from any kind of data. There are nuances because there are text models which can only understand text. There are image models, and there are cross-modality model or multi-modality models which can understand both image and text and then map them into the same latent space so that you can search across them. You can do, say, text search on images. You can search images by text. You can also search images by images. So a lot of very interesting use cases, and we have seen a lot of them from the, the AI applications invented by or awesome developers. And one of the particular interesting use cases is so-called retrieval augmented generation. I mean, from my perspective, it's just what I talked about before plus large language model as summarization. So that you have the typical kind of search-like flow, which is offline, you do the document indexing, and online, you do the query serving by searching through the embedding model, searching through the vector data that you generated from embedding models offline. And then once you get the semantically relevant or kind of semantically relevant documents from the database, now you can compose a prompt by giving it instructions, say, answer the question based on the following information, and then just don't make up answers. If you don't know, just answer, I don't know. And then give it to the large language model, and the large language model will give you a, kind of better summarized output, or kind of reason, using this reason capability, and then do some reasoning, and then give you a more comprehensive answer. Which is also grounded by the actual information from your database rather than making things up like hallucination. So I want to start from here and talk about why I think the RAG is just a new search, why I think they kind of resemble with each other. And if we have, carry this perspective, this mindset, then the problem is like, how do we build better search pipelines so that we can build better RAG, or you can even build better, say, multi-model RAG, something that can answer based on not only on text modality of data, but also on images and others, a lot of fancy stuff. And then I want to kind of envision the future landscape of RAG after that. Yeah, this picture is, I want to say, deja vu out of it, because when I see RAG the first time, I'm thinking, okay, this is just search with something kind of some adapter from the vector database, from the large language model. So let's see how the traditional search system was architected. The architecture is usually consists of two components. One is the offline indexing building. The other one is online query serving. So this is taken from like computer science class from Michigan, which where I did in my graduate school. So on the left side, the index building usually composes data acquisition. Like you can use a crawler, or if you have the data in your, say, if you have the private data from the enterprise, then you have the documents already. You just need to collect them and kind of organize them in some neat way. And then you need to parse the information. If that's HTML, that creates some kind of challenge because you need to render it. But if that's PDF, then you need to kind of do OCR, or you need to extract text out of it. If that's Markdown, then good for you. That's way more, like, that's way easier. And then once you have the information, we call it index building, but this index building is kind of different from the what's that called? The reverse, inverted index from the traditional SQL database, or say graph index that we're talking about in the vector search domain. It's mostly just data ETL. Like, how do you transform the data? How do you understand the data? How do you extract the labels out of the HTML page or images? And then you have a lot of labels. Now you need to build a reverse index out of the label. That's why they call it index, but it's kind of a confusing or an over generalized term. But once you have the data cleaned up, kind of precise and neatly placed somewhere and organized and warehoused, now you have another challenge to solve, which is the query serving. So that in the traditional sense, because we are using keyword-based search, to do things like intention understanding, kind of parse the intention out of the query. But I mean, in this era, like I said before, is that the embedding model it can kind of provide this functionality for you. So like usually there isn't query intention parsing phase, but there are still some phase that's similar. Is like you need to retrieve the data from the index or the kind of offline prepared warehouse. Because I mean, this time the query may talk about some things different from next time, then you need to do a very efficient retrieval. Like in terms of the web search, there are hundreds of billions of documents, then how do you find them, right? Every time you think of, I think hundreds of billions of documents, you need a whole data center to hold them. Not like we're not talking about one single server or something. So that there's a lot of like interesting distributed system problems. And once you retrieve the information, now comes the problem of how do you do the ranking? Because usually the user experience of search was traditionally designed as 10 blue links, so that the order of the links matter a lot. Actually, that means dollars. So that you need some kind of fair and effective ways to do the ranking. And ranking phase was also kind of simplified in the RAG era. Because usually sometimes there is even no ranking. It's just using the similarity score from the vectors generated by the embedding model, and then just use the similarity score as the ranking. There are like more kind of sophisticated ranking mechanisms, like simpler ones being, say, you can use other, say, metrics, like some business metrics to affect the ranking, or some more fancier ones being you can use another machine learning model to do the ranking for you, which is kind of trained for just telling the kind of judging based on the relevance between two candidate documents and a single query. So I mean, if mapping to so this is again the architecture of RAG, where you have on this vertical flow, you're doing query, like online query serving, and on the vertical side, we index the documents into a bunch of vector representations and store them in vector database. So you can see, so this part is pretty much just offline indexing. It kind of maps to the offline indexing of the traditional search. And this part maps to the online query serving. In this case, the serving as large language model as the last component. And not only from the architecture perspective, some of the things are extremely similar between them. So from RAG, it's kind of large language model rules all about query serving. Or, I mean, not completely. We can say large language model plus vector retrieval. Because for vector retrieval, it does the retrieval part and ranking part, and the large language model will kind of do the summarization. You can think of it as, more abstract ways, also ranking, or it's kind of the content consuming, right? Before it's kind of edits the content before it was sent to the end user. And for traditional search, that's, just query understanding, there's matching, there's ranking. There are a lot of product related features, for example, safety, or the diversity of the results. You don't want to just show results from one single source. For the safety, you want to judge based on the violence score. Like you don't want to show like improper content, things like that. So there are a lot of post-processing after the retrieval phase. I haven't seen this kind of complexity or sophistication in the RAG system, or at least the RAG system that most developers are building. So I think that there could be more complexity on that phase as well, going forward. On the offline indexing part, for RAG, there's data ingestion, which is how do you get the data from like the original source of the documents, and then you do good doc parsing, you do summarization, you do some fancy kind of pre-processing other than the most basic chunking and tagging with some kind of metadata. And then you do embedding generation and store them into vector database so that you can search in the future. There are also other things that I mentioned before. For the traditional search, that's usually termed as, you start from data acquisition and crawling, and then you do a lot of data cleaning, and you render the data. You need to render the HTML into some kind of visual content, and then extract the content based on their like relative positions, like a lot of fancy stuff. And then you do semantic understanding, you extract a lot of labels, you build a reverse index. And you also have scoring, which is mostly related to the business objectives. Like sometimes you even need to consider like the advertisement, like there are paid advertisement, which will affect the scoring or ranking in some of the search products. And lastly, once you have done all of those, you need to push the like all of the refresh data to the serving stack. You know, there's a complete serving stack, but in RAG, it's like everything is kind of simplified into vector database, large language model, and pretty much that's it. So with this comparison, I think it's kind of obvious that what the challenges will be going from a Twitter demo to a production-ready, search pipelines. Yeah, just before I dive deeper, I want to do a very quick poll. Like, how many people think? How many people have built a RAG-related application? Raise your hands. Okay, and how many of you think your RAG application is either production-ready or you are thinking of some kind of approach, you are seeking an approach to make it production ready so that you can, serve it to, I don't know, like millions of users. Okay, awesome. All right. So yeah, let's do some very quick discussion or kind of setup before we talk about before I show you a real demo of how we use Spark and Milvus to tackle the scalability problem. Because I mean, there are a lot of developers who are just who just got started with the Gen AI journey. So we used to work on scalability and performance a lot, but very recently we have seen a lot of customers and open source users they just want some kind of easy to get started products, and sometimes they want to run it in platforms with very limited computing resource. Unlike Docker or Kubernetes or gigantic cluster on the cloud, they just want to run it on their laptop and notebook. So that to tackle this problem, we kind of divide the product into two deployment modes. One is called Milvus Lite, which is you can just pip install and then start running it in your laptop or notebook. The other one is the more serious like Milvus that's designed for scalability, but is way heavier than the other one. And you can deploy it on Kubernetes or cloud. And they share the same API. So that the experience of using the Milvus vector database is pretty much similar. You pip install a client. If you don't need like Kubernetes or Docker deployment, then you can start using it right away, just with the client. It will have the locally materialized database, and it will load all the data into memory for efficient vector search. But you probably don't want to store billions of vectors there because the laptops couldn't hold that many. If you would like to have a more scalable option, then you can deploy it in Docker or Kubernetes. And the only difference is that once you deployed it, you will get the server endpoint and also a token for authentication. And then just need to use the same API, but substituting the local file name with the network credentials and endpoint. And then you have the same application working with a way more scalable Milvus deployment, and similar for Kubernetes, but the setup is way more complex. And then you can use the either one of them in the whole ecosystem of AI development toolkit. You can use Llama Index Langchain. You can also use evaluation frameworks. You can use it with various open source or closed source embedding models and large language models. For example, you can use it in Llama Index to build your, Twitter demo. I want to find a better word, but like not that production ready, but way easier to set up kind of offering of RAG or search pipelines. And the API is very straightforward. You just need to define the vector store by specifying, say, the local file name, and then you can use Milvus within the Llama Index framework, and with this native API, such as you can do the insertion with just one function call. And you can also use the LLM-index query API by specifying a text-based query and then retrieve the most relevant content. Or even if you do, I think it's chat or answer, the other API can call the large language model and then return you a more human-friendly, more human-readable final answer, not only the top 10, like top K list of relevant documents.
5 minutes.
And similarly, with long chain, you can do the same thing. I mean, still specify the endpoint or the file name of Milvus, and then use the long chain API to do similarity search and chat. However, if you have 500 million of documents and you are serving thousands of query QPIs, I mean, this kind of architecture is like in-process local architecture may not scale well for you. So that you probably want to think about some more sophisticated setup. One of the setup is using Spark. And Spark is commonly used for the traditional search tech stack because it has this great scalability. It has a lot of toolings and support from the open source community. So the way to do this, I mean, the workflow is exactly the same. You're just using different technology. So you have the unstructured data like images and text, and then you do the pre-processing by either generating embedding models or even better embedding models plus some kind of labels from your purpose-built machine learning models, which, for example, which is good at recognizing if this is a dog or cat or things like that. And then you use the Milvus util function, which is provided by this Milvus Spark connector to push the data to the serving stack. In this case, a vector database deployed locally on a Kubernetes cluster or remote in the cloud. And so the API looks like you just need to set up the Milvus options in this to get the connector started, and then you can write the data in Milvus format. So there are two ways of doing this. One is using format Milvus, which is iteratively insert the records into the Milvus vector database. However, if you have many, this may not be efficient for you. You may want to do a batch, like a batch of 500 megabytes of vectors and other text data, and do this batch search. And you can use the same connector, but just specifying a different format. In this case, I'm JSON. It's just a slight variation of JSON, where you can batch put a lot of data. And you can even, if you want, you can even do the search query from the Spark data pipelines. But usually the Spark pipeline is just for offline insertion, and the online serving happens from a different tech stack. Usually it's self-built application services. And you can check out more details from the milvus.io docs. And we have a lot of integration content. I don't think I can go over the future landscape, but I do want to quickly go through the Milvus.io documentation, where you can find the more detailed explanation of the Spark Milvus connector. And if you want to have some more kind of hands-on documentation, you can click on this. And we have the notebook built for you, which walks you through how to set up how to configure the Spark connector and how to specify, say, a S3 bucket of Milvus so that you can do the batch insert, or how to specify the endpoint of Milvus so that you can do iterative insertion. I think just very last piece, kind of closing thought. I think I'm super excited about the RAG technology, because this makes search a kind of boring decade-old technology kind of popular again. But there are a lot of experiences and takeaways from the traditional search system, which I think is still quite applicable to today's RAG development. The first one is how important it is to make your data right before you even think about fancy techniques. there are like 10 plus fancy techniques in RAG. Like, for example, you can use agent to do the search for you. But before you jump into that, just think about, do you even have the data? Sorry, do you even have the correct answer hidden somewhere from your data corpus? If not, then how do we collect them? And then once you collect them, how do we just do the chunking or other kind of data cleaning so that the correct information is not missing from the final data corpus? Like you may want to grasp every single useful information from your documents, and that takes a lot of heavy development on the data pipeline phase, not even touching the embedding model or the machine learning model part yet. And then for the transformation, you want to make every single part right. For example, for chunking, you need to do a lot of experiments to find the best chunking strategy for you, not a general chunking strategy sometimes. And for embedding models, similarly, do you have a vertical use case or do you have a more general use case? Then you have different embedding model choices. And whether you, if you want to do like more control, like having guardrails on your retrieval, then you probably want to label them with some, say, like access control, right? So somebody can access this information, but not the other ones having those labels on them, or having a more kind of deterministic labels about semantics assigned to them, so that in addition to the kind of fuzzy like embedding retrieval, you can also do rule-based retrieval, and Milvus supports that with metadata filtering, or sometimes called Scala filtering. And lastly, I think right now, a lot of the data, they are generated to be like human friendly, like they are purposed to be read by human. But in the future, I think maybe there will be neural network native data. It's like the point that at the very beginning of the data generation, they are not supposed to be read by human. They are vectors or even some other data types, which we don't know at this moment. So just some closing thought. And also, I mean, for agent is a very hot topic, so that in the future, there may be agent-based search, so that they help you decide whether do I need a retrieval, or I don't even need a retrieval large language model is good enough, or I divide the query into subqueries, kind of doing the query intention comprehending in a way more smarter or easier way. So yeah, that's all from my talk. I mean, this is my contact, LinkedIn contact. So if you want to connect after this, I'm just dropping a message. I'm happy to answer the questions. Thanks.
Thank you. Let's see if we have questions. I'm going to stand on this side of the room. We have time for a couple questions. All right, Jiang, did I see a hand? You see, okay, there's one over there. And then Jiang will be around afterwards if you want to ask one-on-one.
You briefly mentioned multimodal search at the beginning of your talk. First of all, good talk. I want to know like what are the current like best techniques to do multimodal search in your opinion?
I see. Yeah, I think the multimodal search, the really, yeah, here we have a multimodal example, which kind of does a combination of search query from text and image. So I think this really depends on how fast the embedding model kind of advances. So it's kind of one of the observation I'm having is the embedding model is following the trend of large language model. So the first, I would say the first generation of embedding model, they are mostly based on BERT, which is a different architecture than the large language model, which is transformer. But recently there are, the latest embedding models which perform better than the past ones, they are trained with the large language model architecture. There are a lot of explanation of that. For example, if you want to categorize the semantic of the information really well, you probably want to have good common sense in the beginning, so that the large language model has great common sense, so that training on top of that, it will kind of give you some advantage rather than starting from scratch. There are a lot of explanation of that, or kind of guesses from that. But just from observation, if there, like the whole industry is focusing on a large language model, then there's probably just this single architecture will rule everybody, because a lot of resources are put into this, a lot of technology advancements are like happens in this domain. So with the with GPT-4o and a lot of people kind of devoting their effort into the multimodal large language model training, I think soon will be followed by multimodal embedding model training, which kind of shares the same architecture but with a slightly different purpose. So that I think probably in the very short future, we'll see more in multimodal embedding models rather than just right now we probably only have CLIP, and I think BGE has a visualizer embedding model, just two open source available options. But soon after this, I think there will be way more options. And once that's done, I mean, on the vector database side, we are kind of ready for that because we now support multi-vector and we have the great scalability. So once the embedding model problem is solved, I think the infrastructure side will be pretty much ready for this. That's my personal take.
I have a quick question. Okay. What data would you put on Spark and what data would you put on Milvus?
Yeah, I mean, for Spark is mostly data processing, so that you probably want to put like text, PDF files, images on Spark's data warehouse, or I mean, they are competing with Snowflake or maybe Snowflake, I don't know. But on the other side, the vectors and the kind of immediate like raw data from vectors like text and some labels, which will be essential for retrieving, those things will be put on the serving stack. Because the serving stack is way more, I mean, the storage cost is way more expensive than the data warehousing and data processing stack. Because on vector search, all of the data are put in memory. I mean, there are like cost reduction techniques, but in general, it's much more expensive, so that you really, really want to put the final kind of data format in the vector search stack.
Hey, yeah, thank you for the presentation. Quick question. I know that, okay, you are building the vector database and or the vector database, but today, a lot of things are happening on the knowledge graph, right? So it's not just only like embedding, but also with the knowledge graph. Do you have, what's your thought on that? Okay, do you have any knowledge graph interfaces in your roadmap?
Yeah. So I think knowledge graph will be a great complement to vector search. I mean, in traditional search, like for example, in Google, they are using both token-based retrieval, embedding-based retrieval, and knowledge graph. And knowledge graph is a very important piece of it. So we have seen this trend. There are startup projects or open source projects. One of the examples is Whitehall, who also did a presentation in your previous talk. In your previous meetup. So we kind of choose to partner with the projects working on knowledge graph, and I think it will be essential for those technology to be combined so that you have multiple stage and multiple ways of retrieval, and then you combine the results with a fusion or merging phase, and eventually you get more grounded and more comprehensive results.
Just to follow on that, okay, yeah, because the pipeline, we already started parsing the document, and then we are creating the vector embedding. So I don't want to kind of like do 3 or 4 different pipelines to build, right? While I'm doing the parsing and doing the embedding, along that line, I want to kind of create this triplets for the knowledge graph.
Yeah.
So that would be like a lot more efficient for me to kind of like do this pipeline. That's the reason why I asked the question.
Yeah, so just my kind of comment on this, because I was observing how large enterprises were building this, because they have 500 people teams, so that they pretty much build the data pipelines with kind of different paths, and with the same original data, they also, they both do embedding generation and say knowledge graph, like knowledge extraction and building the graph based on their relations, kind of comprehending on their relations. So that with Spark, it's easy to do that. I mean, easy in under quote, because you have the graph so that you can define graph with a lot of nodes. I won't be surprised if you see a graph with 500 nodes. That's what I have seen from my previous experience. The other thing is, I mean, probably a lot of developers, they don't have access to this resource. So that what we suggest them to do is to, just look at the open source options and startups working on this domain. And we also partner with them. We are also sourcing those partners so that we can integrate Mills into their solutions to benefit our users and developers.
All right, let's thank our speaker again. So our next speaker is Shangyin. Oh, excuse me. Our next speaker is Shangyin Tan. He's a second-year PhD student at UC Berkeley, working with professors Kaushik Sun and Matej Zaharia in the programming systems group, the Skylab. Previously, he was a student researcher at Google DeepMind, back when it was still Google Brain, and he's recently contributing to DSPy. So he's going to speak to us about programming foundation models with DSPy, or declarative self-improving language programs, Pythonically. Welcome, Shangyin.
Okay, thank you, Christy, for inviting me here. Thanks to everyone for being here. We had 2 great talks, and all these talks about language model pipelines. So I think this is what DSPy is trying to address. We want to build a framework for everyone to build language model applications, language model pipelines easier. And this DSPy project is a large community project. We have a lot of contributors. It's an open source project. Here is a small star charts of DSPy over all the Stanford NLP projects. So the pink one over there is DSPy. So yeah, maybe I'll just do a quick show of hands first. So how many of you have heard about DSPy? Okay, nice. How many of you have used DSPy? Okay, great. We have a lot of people here familiar. So hopefully you can learn something new from my talk. So the first thing I want to say, I already said this, it's never been easier to prototype impressive AI demos. So with all the language models, so whether it's open source or proprietary, where you use your API to call some of the private language models, it's very easy to build all these demos. And one such thing we can do is that, obviously, the easiest thing we can do is that we can build a chatbot. We can ask the language model one question. So we ask the language model, when was the Stanford University founded? And the language model gives us quite impressive results. I think we're not able to get this kind of paragraph results 10 years ago. However, the problem is that it is not correct. It says Stanford University was founded in 1891, which is not correct. It's funded a few years before that. And so the thing that we want to do in DSPy is that we wanted to turn the monolithic language models into a more reliable, complex AI systems. And I think this remains a very challenging job for every one of us. There's actually another problem. So it says it was named after Leland Stanford. So it was actually named after the children of Leland Stanford. So there are a lot of problems in the language models. And the language models sounds very confident about the answer. This is one of the problems we have. I think in the first talk, we're seeing that if you use language model as a judge, sometimes the language model will try to give you a good answer, but it's actually not what you would expect as a human. So now we want to introduce the DSPy paradigm. So DSPy paradigm is quite different in building large language model applications. So what we talk about here is that we wanted to program and not prompt language models. So everyone here knows how to prompt language model. You give language model some text, describe the task you want the language model to solve, and then boom, the language model will give you some response. This is not what we want. What we want is to have a very systematic way to program a large language model application so that it is actually very reliable and optimized. And we'll see how this works in a second. So this talk will be very practical. I'll go over a few DSPy programs to solve a few different tasks. So first, I want to introduce a few very important DSPy concepts. So the first one is called signature. Signature is essentially natural language types for your AI applications. As we all know that a function could take an integer as a type. A language model takes some sort of information as input and generate some other sorts of information. So now the language model is multimodal. It can generate image, maybe sound as well. But right now we'll just focus on the text. So here are two examples. If you're building a question answering system, your input is question, your output is answer. If you're building a summary for a very long document, then your input is a long document, your output is a summary. The second piece in DSPy is called modules. So modules are essentially abstractions for your language models, your retriever models, or some external tools. So in DSPy, all these are encapsulated into the modules. So we could have, for example, chain of thought or React as one of the modules. The third thing is that in DSPy, you don't have to do manual prompt engineering. This is the biggest advantage of using DSPy. So the first thing in DSPy we have is called optimizers. Optimizers are, as their name suggests, they optimize your DSPy programs. The large language models, they optimize them by turning them into few-shot prompting or fine-tuning them. And the second thing I want to talk about is assertions. So this is another abstraction that we introduced into DSPy, where you could assert on some quality of the responses of the language model, and then DSPy will try to automatically find the best way to adhere to those constraints. So yeah, let's get concrete. Our first task, question answering with Hotpot QA. So Hotpot QA is a data set with a lot of questions, and each question will associate with a few passages. So this is a very classic RAG problem where the passages are essentially taken from Wikipedia. So all those knowledge-based questions could be somehow answered by some of the passages in Wikipedia, but your job is to find those passages and then use this to answer the question. So the first question we can see here is that it asks how many stories in the castle that David Gregory inherited. There are essentially two problems in this question. So one is which is the castle that David Gregory inherited, and second question is how many stories are in that castle. So the first DSPy program we can build for this task is very simple. So it's just one module, one chain of thought module. So we can write the program like this. The COT, the DSPy program, is a chain of thought module from a question to an answer. And if we ask this module this question, the language model, whatever underlying language model we're calling here, will give us a quite unsatisfying answer. It says, Castle Gregory has 3 stories. This is definitely hallucinated. So we can build another or a slightly better program, a RAG program in DSPy. So this pipeline is a little bit more complicated. It has one more module called retriever. The retriever will try to find some of the relevant passages from the database of Wikipedia. This is the DSPy program. It looks more complex, but it's actually not. So if you're familiar with PyTorch, this thing will look very familiar to you. So you define a bunch of modules in the init function, and then in the forward function, you define how you would want to use those modules. So in the forward function, we first call retrieve on the questions that we receive, and then we try to generate an answer with all the retrieved passages. This is also a very easy, boring pipeline. And if you're using this pipeline, the retriever will give you this piece of information. Says that St. Gregory Hotel is a 9-floor boutique hotel. And then the language model try to use this information to answer the question and got the right answer. So the next thing we can do is that we can build a more complex, more involved DSPy program. So this is what we call a multi-hop retrieve augmented generation. So it is multi-hop in the sense that we don't directly query the retriever using the original question. We ask the language model to generate a question for us first, and then we use that question to ask a retriever. And we can do that in a lot of in many multi-hop ways, so that we do that more than once. So we use all the retrieval information in the first round. We ask the language model to, I have this kind of information. I want to answer this kind of question. Can you generate me another query? And then this program will look like this. It's not, it's actually just like you're adding essentially like 2-3 lines to the previous program. You define another module here called generate query. So the input to generate query is the context we have retrieved so far, a question, and the output is a query. And then the input, the signature of the generate answer module is you have a bunch of retrieved context, and then you have a question, and then you're generating an answer. So if we do this, we can see that the language model actually asks like very meaningful question over there. So they ask, which castle did David Gregory inherit? So this question will actually give us a more precise retrieved context compared to the previous one, where we just query the retriever using the original question. And by running this pipeline, we can actually get the correct answer at the end. So the next thing we want to talk about is the optimizer in DSPy. So the optimizers in DSPy is also a pretty simple concept. So if you're familiar with a concept called in-context learning, which is essentially turning your task into essentially turning a prompt of describing a task into a multi or few shot fashion, where you try to give the language model a few demonstrations of your task, and then you ask the language model to solve another task, which is your general task. So what DSPy compiler can do here is that if you give a language model, or sorry, if you give the optimizer a DSPy compiler your DSPy program together with a few examples that similar to the task you wanted it to solve, and then you give that give the compiler another metric or evaluation function on how well the language model performs, then you can automatically use the DSPy compiler to construct that few shot example for you. And a lot of times, if you only have the input data, that's fine, because DSPy can bootstrap all the output for you using language models. And the good thing here is that you can compile your program. So for example, you only have like very low budget. You only have like, for example, your model is T5, it's a very small model with like a few million parameters. You can still use GPT-4 as your teacher. So GPT-4 can bootstrap very high response, high quality demonstrations, and then you can use that, put that into the prompt. Because compiler, I think we want to make an analogy to traditional software where compiler is something you run only once, and it compile your program into a more optimized version. You don't have to run that in the future, and the cost of running the compiler is amortized through all your usages. So if we compile this multi-hop program, the first query, the first module will look something like this. It's very complicated. So all of these are few shot examples where we choose from the training set. And these are useful few shot examples to teach the language model how to ask a question about another question. So how to generate the search query. There are a large basket of optimizers in DSPy. There are a lot of optimizers, for example, labeled few shot, the bootstrap few shot with random search, and then ensemble, a lot of that. There are more optimizers coming along. I think this is the main direction of development of DSPy. We're trying to develop more optimizers so that you can use those to not only like turning your program into a few shot program, maybe you can do something like optimize the prompt as well. Okay, so yeah, I wanted to, this is, so far we have talked about how to define a program in DSPy, how to use optimizers in DSPy. And the next thing I want to talk about is how you can build assertions in DSPy. This is another very important concept in DSPy. So the next task I want to talk about is a data set called GSM-AK. It's a very famous data set for grade school math. So all the questions are essentially some textual-based math question. And the questions themselves are very easy, and the answers are supposed to be a short integer. So here, the first question, it says, 20 birds migrates from one lake to another, from that lake to another in 2 seasons. 50 miles from for the first travel and then 60 miles for the second travel. And the correct answer, to calculate the combined distance is to add 50 to 60 first and then times that with 20 birds. So the first DSPy program we can build is very simple. It's just that one module program. So we write it in this way, but you could write this in a one-liner as well. So this program essentially just have one chain of thought module that takes the math question and it gives you a math answer. And this is what DSPy will generate. So all the black thing here, the black text here is what DSPy will bootstrap out of that program. So DSPy will, because we're using the chain of thought module, we're expecting the model to output the reasoning as well, so that in the format section we have another field called reasoning, and the green part is what the GPT 3.5 will generate for you. So GPT 3.5 says all the birds fly 50 miles and then 60 miles, so the answer is 110 miles. This is definitely not correct, and there are two problems with this. So the first problem is that it does not even contain there are 20 birds in the reasoning. The second thing is that the answer is like a very long, complicated sentence where we're expecting a short numerical answer. So the language models are not following what we expect, and actually the bigger problem here is that we don't even have a way to specify what we want in the DSPy programming model so far. So the only thing we can do here is to manually put our constraint into the prompt. This is what a lot of manual prompt engineering or prompt engineers will do in their day-to-day life. The model is not generating this, so I just put this line into the prompt, hoping the model to do this for me. So our goal here is to enable the DSPy programmers to define constraint inside the DSPy program. And we want to make this a very robust, extensible programming construct instead of manually adding sentences to the to the prompt. So we want to introduce assertions in DSPy. So we have two kind of assertions. So one is a harder assertion, DSPy assert. Another one is a softer assertion called suggest. So the language models are not reliable. They're probabilistic. So a lot of times we may not get exactly what we want. So in some of those cases, we can withstand that small error. So we introduce the suggest, where you try to make a language model to follow what you want, but it fails. The API is very simple. It's pretty similar to Python's assert. You first give a constraint and then you give an error message. But here we call it an instruction message instead of error message. And I'll see how this comes into play in a second. DSPy assertions essentially enable two things. So first is that if one of the assertions failed, we're actually able to backtrack into the failing language model and ask the language model to do that again. This is really cool. And the second thing is that when we use DSPy assertion with a compiler, with a DSPy optimizer, it enables better example selection and bootstrapping when you're trying to do in-context learning with your DSPy program. So we can see that how we can add assertion to this program. So we introduced two helper functions. The first helper function extract all the numbers from the question. The second helper function essentially tells you whether the rationale or the reasoning has all the numbers of the second argument. And then we can add two simple suggestions here. So the first suggestion says, the rationale or reasoning should contain all the numbers appeared in the question. So if the language model is able to pass this suggestion, it will not left that 20 birds thing in the reasoning in our previous response. And the second suggestion is we say that the answer failed should be a short failed because we're expecting the answer to be a number. So let's see what the language model will do for this particular program. So in the first run, in the first call to your language model, it will still generate the same response because the program execute this line, this plat line here, so it hasn't seen any of the suggestions. And then what happens is that the first suggestion evaluates to false because this rationale has numbers, it's not false. You don't really have the number 20 in your reasoning. And what happens is that we will backtrack to the erroring module, and then what we'll do is that we'll put the previous reasoning into the prompt as well, together with the instruction that you provide in the suggestion message. So right now, the input will contain additional information to tell the language model that your reasoning should contain the number 20. And in your previous response, your reasoning doesn't even have this number 20. And if you include this information in the language models, like magically, this time GPT 3.5 is able to generate a correct reasoning with that 20 birds somewhere in the reasoning field. And one problem we notice here is that the answer part is still a long sentence. And then the first suggestion passed, the second suggestion still evaluates to false. And then essentially we do the same thing. We include that previous answer into the prompt, and then we include the instruction as well. And now the language model is able to generate something satisfying for us. So and then now I wanted to talk a little bit about example selection and bootstrapping. So this is also very simple. You just use your existing DSPy optimizer, and then you call the DSPy optimizer or compiler on the program with assertion, and it just works because it naturally works. This kind of thing, the assertion in the DSPy program enables three things basically. So the first is that the demonstrations that you put into your context needs to pass those assertions as well. So a lot of times you might have some example that looks good. You have a correct final answer, but the intermediate steps is not correct. Once you have all these assertions that guards the response of your intermediate module results, it helps you to actually select better demonstrations. A second thing is that the demonstrations now can also contain traces and errors and fixes. So the demonstrations essentially could contain previous response and instruction, and now the correct response. And we find that this kind of demonstration actually helps the in-context learning a lot. The third thing, last thing, is that optimizers is assertion aware. So essentially, the optimizers are aware of how many assertions your candidate program can pass when you're compiling a program or when you optimize a DSPy program. So here are some of the results. So if you just use a simple chain of thought on GSM-AK, you'll get 61% roughly. And if you use assertion, remember, this is just like 5 lines, 6 lines of code. You can get 74%. And then if you compile stuff, it gets even higher. So in this particular example, compiled with assertion does not really perform, the vanilla compiled version, but we do have some more complicated. For example, we're trying to generate tweets, generate quiz questions in the GitHub repo that you can check it out. And in those cases, sometimes we find that in context learning, compiling program with assertions performs very well compared to the non-assertion version. And here's another application I wanted to quickly mention about. So human eval, a lot of people here should be familiar, is the code generation dataset, where the input is essentially a short prompt, a signature of a function, and then you're expecting to output some code. So this is the DSPy program you could build for that. It's exactly the first program that we built for the math problem. So the only difference here is that the input is prompt, and the output is code. So this is the code generation pipeline. So it's very simple. And we can actually build a more complicated pipeline for this particular task. So we can actually ask another or the same language model to generate some tests for us. So for the same problem, we generate code and tests at the same time, and then we can use the test to verify the code. This is not like 100% accurate because there are some problems with this approach. I'll talk about that later. But sometimes, we found that the generated code can be rejected by the generated test. And then once we found that, we add a suggestion here says that your generated code should pass your generated test. And this is the DSPy program you could write. Essentially, you define another module called generate test in the init function, and then there's a helper function that checks whether the sample of the code passed the test. And then you can add a suggestion here. If it doesn't pass, we'll just say that the generator code failed the test, and then please fix whatever error you're seeing in the execution. And this improves the human eval by 5% on GPT 3.5. It's not a huge increase compared to the previous example. So here are two problems with generating code and test. So sometimes both test and code are run in the same way. So the language model doesn't really understand the problem. It understands the problem in a different way. So the code and tests are not correct. And the second thing here is that the generating test can be wrong, right? You can just, the language model is not strong enough to predict the output of the specific task. So that it simply failed. Yeah, I think this is basically all I have. I have 3 notebooks. The first one is the GSM AK, second one human eval, third one is the first intro notebook, that the multi-hop back pipeline thing. So all of these are, so we have cache, we have built cache for all of the notebooks. So you don't have to pay any of the OpenAI credits. And here's my Twitter, so feel free to connect and chat with me afterwards. Yeah.
Thank you. See, are there any questions? That side of the room. Okay, there's one.
Hi, thanks for the great talk. I have one question. So if there is a problem of forcing LLM to output a certain format, like let's say JSON or like a number, would you like suggest going with a signature approach of like prompt to int, or would you suggest like an assertion type approach?
Yeah, this is a very good question. So in one of the experiments, we found that if you add your instruction to the prompt, so let's say in the prompt, you say that please output JSON. And then compare this with adding an assertion that says, the output should be JSON. Actually, the assertion approach performed better than putting stuff in the prompt. Yeah, because the assertion approach, essentially, it requires more compute. When your model is failing, we actually backtrack. So we're going to call the language model again. So it's essentially, I think you could think that out as of we're sacrificing some of the compute because we're doing things multiple times, but we want better result. This is useful in a lot of cases where you have like a bunch of computes to span. Yeah.
Yeah. One more question. So if there is a, like, let's say I have a demonstration data set, like what is the ideal way of like, how much do you need for like training your prompt versus testing? Like, can you give like an ideal split?
You're saying that you have a demonstration data set and then you want to use that to optimize your prompt? Is that?
Yeah, using DSPy.
Yeah. So we actually found that if you're just having like 50 to like a few hundreds demonstrations examples, you can get very impressive results. So in one of the recent medical data set, like medical competitions, some group in University of Toronto, they use DSPy and then they're leading the second place by like 20%. So the second place is 60 something and they're 80 something. Just using like, I think around 50, 100 examples. Yeah.
Thank you so much.
Yep.
Hi. Would you mind explaining a little bit more on how optimizers work, especially when you have a particular metric that you want to optimize for? How does it work and how does it actually translate to the prompt?
Okay, yes. So for example, I can use the example. Let's say we wanted to build a few shot prompt for your language model. So essentially what we do here is that we first bootstrap all the examples, meaning that we run the program over all the inputs in your data set or in your example set. And then we apply your matrix function, your evaluation function on the outputs. We select that one. So we select those that are good. And then we essentially doing some discrete search over all the examples that are good to determine, which of the examples should I put it into the prompt for, ideally the user would also provide a validation set so that we can use a validation set to validate which of the combinations are the best. So the search process actually takes a lot of time, but as we just said, this is a compiler, so you only run it once and then it works for all the future, yeah.
I studied computer science. I'm interested about medicine and biology. So I focus about the DNA and RNA. So my project called Alpha MD. So I want to building some website our app. So organize whole laboratory, medicine laboratory, DNA and RNA data together. Because laboratory didn't open data science for everyone. So I want to open something website. So, but my question about what do you think AI tool plus medicine, something research have opportunity? Thank you.
Oh yeah, that's a very good question. So I have also been looking at some of the bio applications as well. I think the hardest part of that is how you would define your evaluation function. So a lot of times, when you're trying to generate some let's say you're trying to generate some protein, and then how you could tell that if that protein is a good protein or a bad protein, or how you could even tell that what are some of the properties of that protein. I think those remains a very hard challenge. And some other challenges that I've seen is that a lot of times the data set is missing. So you want to train a model and then you don't have the good data set to doing that. I think maybe that's the reason why there are not like a huge number of bio-related models out there. Yeah.
Yeah, let's thank our speaker, and you can find him afterwards.
Yeah.
Yeah. Thank you, Shangyin.
Thank you.
So next we have a community demo from Secludy, and I will let you guys go ahead and introduce yourselves. And while you're getting set up, was there anybody who had a job that they'd like to announce? Going. Oh, was there somebody over there? Yes.
Hi, well, we are Kaya AI. We're backed by Soma Capital. We're looking for a head of ML. We're focused on disrupting the construction supply chain. So trying to connect distributors to logistics providers to general contractors in the construction industry. So thank you.
So look for, what was your name again? Johnamy. Look for Johnamy. Anybody else? Okay.
Yeah, first I want to start by thanking Christy and the Milvus and Zilliz team for letting us present. Milvus has been a really important part of our tech stack for one of our use cases. So yeah, I'm the founder of Secludy, and here's my co-founder Ming. We help companies fine-tune language models without the risk of leaking PII data. And with that, one of the biggest use cases for this is actually generating privacy protected synthetic data. So we're an alternative to data masking, where data masking is more at the data level compared to what we're doing. We're approaching privacy at the model level itself by using a technique called differential privacy. So differential privacy involves adding privacy preserving noise during the fine-tuning process as a way to be able to obscure the impact of any individual data point on the model while still having very high accuracy. You won't be able to pull out the individual PII data points, and you also have like provable privacy guarantees, which will make it a lot easier to be able to present this to your legal or compliance teams, especially if you're shipping a language model that's publicly facing. This slide right here gives a little demonstration of from an XKCD comic about just like how vulnerable language models, especially fine-tuned language models, are when it comes to fine-tuning with sensitive data sets on like, your data can be leaked in very unexpected ways. So yeah, I'm gonna turn it over to Ming.
Hello, everyone. So I'll give you a high overview of like our synthetic data generation pipeline. So as you can see that we may have some private sensitive data, let's say that could be some use case for a job application a writer writing by the bots. And the training data has lots of PI data, such as their name, their industry, their years experience, and the XYZ contact, where they live, where's their potentially email address. And then, as traditional machine learning methodology, we split in the data sets into training, validation, and also testing. And here that we do differently is we do the DP fine tuning, which is short for differentially private fine tuning. And then we could use open source pre-trained large language models such as Llama 3 or whatever your favorite open source large language model and do the fine tuning. And here, how many have you heard of LoRa? Okay, so how about those? So for the people who are not familiar, LoRa is a technique that to fine-tune the large language model very efficiently, such as we had pre-trained with colored in blue, and then we freeze those, and then we add a metric A and B, and then you can see there's bottleneck determined by the R. That's we could do, let's say, only touch originally like 1 or 2% of the original parameters. So that is become really, really popular, not only in text community, also in the image generation, such as you could train your favorite LoRa on your own PC with like 12 or 24 gigabits VRAM, and then you could generate a lot of amazing output. You can see they change the model behavior and then style, but you can see that the effect is really amazing for the stable diffusion community. And then here, how do we do the DP LoRa for text? So we add a Gaussian noise, such as determined by the following the distribution. And then this sigma is determined by how much noise we want to add into that. There's a calculation that is a little bit complex, but let's say they don't have a closed form or analytic solution for that. So we had to do lots of assimilation and then approximation to get the desired level. But usually you probably choose epsilon as 4 as a rule sum. And then you probably observe a little slight, very slight drop in the performance of your downstream task. So this is our how do we fine-tune the model with the DP LoRa. And then here, next one is once we fine-tune the data, fine-tune the model, and then we want to generate synthetic data, and then we do the sampling, such as using prompt. So this prompt is based on, let's say, we assume that the label, let's say the job description of the occupation and also year description is not private, and then use those labels and the classifier to generate a bunch of the synthetic data. So to give a little bit more details, such as we want to write a job location for a photographer with many various years experience, and we do this many, many times. And then we are calculated embedding distance between the private sample and then also the synthetic candidates. And here, shout out to the Melvis that we could stand up our IVP really fast, and then has a open source community, and then project has great support. And also in the future, we have we want to deploy into the cloud, it has scalability and the reliability. And here we have the colored in red is our private data sets, a private sample embedding, and then the blue one is the synthetic candidates. So we measure the distance between them and select the top, let's say 5, top 10 candidate to the original set that is more similar to original synthetic meanings. So after that, you could evaluate your samples, your synthetic samples qualities, such as one property of any downstream model trained upon the synthetic data also inherit the, let's say, the DP property, so which means like your privacy is protected. And then you could split your data into train validation and then train your downstream models, and then using the static data to do the final evaluation, such as calculate precision, record, F1 score. And then this is not the, we also offer comprehensive and holistic synthetic data evaluation, such as we could calculate the FID score that is based on the mean and covariance of the embedding features, and also MEL score, or such as cal divergences, and also the other quantity such as text length distributions. And also we could also evaluate your production model, right? After we deploy a model, how did that perform? Let's say we could use automatic chatbot evaluation that is very cheap and fast, such as Apaca evaluation that's open source as well. Such as we could compare your DP fine-tuned with normal fine-tuned, how much score did you lose, let's say vice pairs. And then also we offer, let's say red team simulation attack that is such as we try to build smaller model, machine learning model to try to inference the membership. Is this member A inside this training data sets? And next I will give you here one example that we use here inside the training data set, such as this one is a job application demo that has Alia, who is a content, and his phone number and his email address, and then you can see the output has full of his names and also his personal identity. And then we train upon this model, and then we going to switch here, such as we could ask that what is the email address Alia Keller. So for the model that is fine-tuned upon original training data set, private data sets, they will leak this message. But for the DP LoRa that with the message, they will block these informations. And for another example, we try this one. This will take a little bit longer. We want to write 3-sentence cover letter about Alia, and then with contact information to see how those model will perform. Here we go. So you can see that they have the phone number, but this is very different than the one that is the private training data set. And also you can see the model up here that is without privacy protection could leak the original data that is sensitive. So with that all being said, we have conclude our demo here. So there are many benefits because we are using DP LoRa that is only trained upon 1 or 2% of the parameters, then it's 100% faster and then cheaper. And then that will drastically reduce the client compliance cost. And also it's a plug and play. Currently we're trying to deploy into the Snowflake. So if your data is within Snowflake, there's no need to transfer your data to a third-party cloud databases. Also, we could offer the container services to deploy on your favorite cloud environment. And then we offer a really high privacy protection guarantee. Currently, if you have 8,000 records, then from the mathematical proven point here that we offer 99.9987%. So really, really high privacy guarantee compared with the data reduction methodology, which is probably like they could guarantee like anywhere ranging from 93% to 95%. So please contact us if you have any questions, requests, and then if you want to see more demos. Thank you very much.
Thank you. Okay, fascinating stuff. I did not know DP LoRa could be used that way. Any questions? All right, so people are going to catch you afterwards. Yeah, so everybody find your people, and we want to thank you for coming. And we always like to close with, we hope you learned something new, met somebody new, or changed your mind about something. Thanks.